Injection can be a sort of a security vulnerability in and of itself, or it can sort of serve as the first step in other forms of vulnerabilities, okay? And so if we look at kind of the textbook definition of injection, which is the first bullet here on the slide, it says, injection is when an attacker sends data to an application, which is then used by the application to execute an unintended command or access data without proper authorization. So in other words, something is coming from the client, and then your web application is taking that data that's coming from the client, doing something with it. However, because of what's being sent from the client, the sender is managing to have your application do something that you didn't really intend, or to show some information that you didn't really intend to show, okay? Now the key here is that injection should be something that you think about all the time, and you look very carefully at any time that you are using something that's coming from the client to perform an action. So in other words, you write code that does something, reads from a database, writes to a file, whatever it is. However, how you do that is influenced by some information that's coming from the client, okay? If that's true, you immediately have to be thinking about injection. There could be a possibility for injection, or maybe not, but you got to be asking the question at that point, okay? And it can be any action. So a lot of people, when they hear injection, they immediately think, you know, SQL injection, sure, but there's all sorts of different forms of injection when you're doing things like accessing files, or reading from XML, or redirecting the user off to somewhere else. Very common in a web application. A user tries to go somewhere in the app they're not allowed to go. So what do? Well, you send them off to the login page, and then after they successfully log in, you send them back to where they were trying to go initially. How do you usually do that? Well, when the user comes to your app and they're trying to go to that place that they're not allowed to go, yes, you send them to the login page, but when you send them to the login page, you also include as part of that response the URL of where they're trying to go, as part of the query string, hidden form field, whatever. Now, after the user logs in successfully, that submission, when they submit the login form, includes as part of the form submission, because it's in a hidden form field or something, where they were trying to go. So back on the server, after you've successfully authenticated them, you then use that information to figure out, okay, now where do I need to redirect them to now that they've logged in successfully? But you're performing an action, redirecting them somewhere else, based on something that's coming from the client. That's a possibility for injection. What if some person in the middle was able to replace that hidden form field value with some different URL, so that after they log in, we don't send them to where they were trying to go, but send them over to my site or something, right? So any action, if it's performed based on something coming from the client, we got to think about it. I had a client one time where, again, they had a SQL injection in that case, but I said, you're building your SQL queries based on this piece of information here that's in the query string. That's user input. You can't do that. And they said, well, that's not user input because the user doesn't put that up there. We put that up there programmatically. I said, you know, the user can like move their mouse up there and click there and change it to whatever they want, right? Oh, yeah. Oops. So bottom line, right? When you're coding your web application, you can never, ever trust anything that's coming in from the client, because that's all stuff that's easy to change, modify, you know, whatever, okay? Now, there is an exception to that, which is if you can use something to protect that information so that it can safely travel to the client and back to the server, and you have a way to validate that information hasn't been altered or modified in any way, then you can trust it. Now, how do you do that? Well, typically it involves some sort of cryptographic work, right? So if you can take the information and encrypt and sign it, include that in a hidden form field, then when it comes back, validate the signature and decrypt it, well then sure, you can trust it. But unless you're going through the effort of doing that, you can never trust anything that's coming from the client. Now, what I tend to find nowadays is that people tend to go ahead and put in the effort to check for issues with like the values that are in text boxes. So there's some form they fill out, and there's a value for last name, first name, and stuff. And so they'll check those values because that's stuff the user types into the form. But what they don't spend as much time checking is things like hidden form fields or drop-down boxes, right? So something like a drop-down box. People don't think about performing data validation on that because they say, well, if you're logged in as a user, you get 3 choices in the drop-down. If you're logged in as an admin, you get 5 choices in the drop-down. So, you know, I don't really need to validate what you picked because you only have 3 things to pick from. Well, yeah, but remember, a drop-down box value is just what gets submitted to the server. So the user can submit anything for that, or they can craft their own response or whatever. So just because you didn't give them that as a choice doesn't mean that that's not the value that might come in as part of the form submission, okay? So you still have to validate things like drop-down box choices or hidden form fields, easy to change. People think cookies have some special attribute to them that makes them, you know, less susceptible to modification. But cookies are just strings of text that are sent in headers, just as easy to change, okay? So another one that comes up quite often now with injection is that I see people, and what they'll do is they will log information about individual requests into their database, for example. And so as part of the log entries that they end up writing, they'll write the IP address of the request, the user agent string, so you know what browser they're using, and some other information. Well, they don't bother doing any validation around the information that they're storing in the database for the browser type, the user agent string, because they're like, well, that's just a header value that I'm retrieving from the request. Exactly, it's just a header value in the request. So I, as the evildoer, can submit anything I want for the user agent string header. I could put some evil injection SQL stuff in there. And so now what I see often is people will end up having injection vulnerabilities for stuff like that, right? Where they're recording the user agent string or the IP address of the end user because they're just not, they're thinking that that's sort of special data when all it is just text coming in from the client, which can be easily changed, right? Okay. So our most common form of injection, SQL injection. This is one, again, we don't see as often anymore now because people tend to be using frameworks where there's protection for this, you know, by default, but it's still one to be aware of, right? So, because it's still very, very common out there. Simple test for if you have SQL injection present, put a single quote into your search box or whatever, see if you get an error. That's usually a giveaway. And then once you've got that, then you can start being creative about how you can craft your exploit. So in the WebGoat here, one of the exercises that I typically will have folks do if they can is under injection and SQL injection. I think it's, yeah, this one. So we've got a little form here that you type in an employee name. So it says that up here in the description, you're an employee named John Smith working for a big company. And then you can retrieve information about yourself. But in order to do that, you have to supply your last name as well as some sort of little authentication code here. And then it retrieves, you know, my name, my department, my salary, and what have you. And so the challenge here is it says, try to come up with something that you can type into these boxes that'll give you all the records of all the employees with all the information, right? Now, sometimes what I'll do is I'll give, you know, I'll show this before the break, and I'll tell everybody during the break to see if you can figure out how to do it. Really, the way this typically works with something like this is once you determine that there is a SQL injection possibility, then you just sit back and think in your mind, I wonder what the code looks like for this. And so sometimes what I'll do is I'll even open up Notepad or something and I'll write it out of what I think the code probably looks like on the back side. And so you might come up with something like this, right? Select star from employees where last name equals, and they're taking whatever I type in for name, and auth10 equals whatever I type in for the second thing. Well, if that's the way they're building their SQL, shouldn't be too bad, right? I should be able to do something like, well, how about if employee name, so last name equals single quote, Smith, single quote, or, right, 1 equals 1, then I don't need the trailing quote because that's already there, right? And then I can maybe do the same thing with the authorization thing, you know, or just trying to get creative here about how we can make the where clause evaluate differently, right? Now you got to make sure it still comes out as a valid SQL statement. However, what I could do here is instead of I could just do the or 1 equals 1, and then semicolon, delete from, and all sorts of crazy whatever I want to do. Basically, chain on additional SQL statements. And then when I get to the end, I can just semicolon dash dash, which is a way that I can tell it to just kind of ignore the rest. All sorts of variations and everything on this, but just trying to sort of visualize what the code looks like so I can figure out what I need to type in here, make sure I got the single quotes in the right place and all that to get it to evaluate the way that I want. Now, this doesn't work really well here because when I try doing something like this and I submit this, that's when the intermediary on your guys' network sort of jumps in and prevents me from doing it. But that's all right. So like I said, if you got time after the training, you know, go here, try some of these. This one's a pretty easy one. However, then we go on to some of these other ones and they get much more kind of involved and interesting and they challenge you with different things. So, you know, feel free, okay? Now, and there's some books and some other things I'll mention to you guys tomorrow that if you're even more interested and you want to dive even deeper into sort of the attacker side of things, I can show you some resources for that because it can be kind of fun to see all the interesting creative things you can do. One of the best ones I ever saw was for that value for that text box, there's a big encoded value that the server would decode and then execute, and what it would do is actually be able to find all of the tables in my database, iterate through each one of them, iterate through all the columns of each table, finding out which ones were of a text type, and then insert a script tag into every text column of every table in the entire database, just with one like, it's pretty cool. So you get all sorts of fancy stuff. Okay, so from our point of view here, there's a few things we want to make sure and do. One, which we already mentioned, make sure database error messages are not returned to the client. So we said that earlier. You've either got your web framework or your web server configured not to send those detailed error messages down. Give the user a nice, friendly error page. Log that, what actually happened, log that away somewhere so the developers can go back and look at it later. And then, of course, what about SQL injection itself? Well, we don't want to be doing, it was on the page there, that string concatenation generator SQL, obviously. So a few things. Depending on how you're accessing your database, let's go back over here real quick. So instead of you writing your SQL in this sort of style, instead we could use parameterized queries. So if we're using ADO.NET, in .NET, we would say, you know, select star from employee where last name equals parameter and auth10 equals parameter. And then on separate lines of code, we specify the values that should be used for those parameters. So what happens is when this query is submitted to the database, the parameters are submitted separately, so the database server understands that those are parameters. And so worst case scenario, you may end up with some weird looking SQL inside your database, but it doesn't actually get executed by the server, right? So that's sort of key. If we're using stored procedures, it'd work the same way because those are still just input parameters that are provided to the server. So same kind of thing. You don't have to use stored procedures for this. Parameterized queries work just fine. So they'll both do the job. If I'm using a higher level database framework, so something like Entity Framework in .NET, for example, Entity Framework will generate the SQL for you. And when it generates the SQL for you under the covers, it uses parameterized queries. So you're just protected from SQL injection kind of by default. It also helps with things like single quotes in people's names and things like that. So it's handy, it's convenient. So bottom line here is, you know, when you're doing your own SQL, you should at least know, am I using parameterized queries, or am I using a framework that used parameterized queries? And then you'll be in good shape. Does that mean you should still be doing some like filtering? In other words, your code should be looking at what name is and what auth10 is before you go to pass it into your query? Sure, but you shouldn't be depending on that sort of filtering code to exclude out injection stuff, right? Make sure your underlying mechanism that executes the SQL will not execute that no matter what. And then, yeah, you probably want some filtering code and stuff in there that looks at these to make sure that, in this case, it's just a select, so it's not a big deal. But in the case of something like an insert or an update, you want to make sure that stuff doesn't get into your database, you know, as best you can, right? Cool, but yeah, SQL injection. But the main takeaway I want to make sure from this section for you is not so much the specifics of SQL injection, but just that injection is always something you're thinking about whenever you're performing any action with something that's coming from the client. How do you write good validation code? Depends on what kind of data you're receiving from the client. I mean, if you're coding up something like a content management system where you're letting your users actually submit HTML and stuff to your server, well, it's very different than if you just have a form where you're having people submit, you know, their name or something, as far as how aggressive you can get with your validation code, okay? But we want to make sure the underlying mechanism there is not going to allow it. Now, another thing, this idea of least privilege. So, okay, I'm using parameterized queries. I don't have a SQL injection problem. Happy, happy day. Okay, but I'm not going to stop there because I also want to think about, okay, what account am I actually using to connect to the database server and execute this query? And what permissions does that, you know, connection string have that I'm using? Now, the vast majority of people that I see that are doing things like .NET applications, you look in their web config file or their app settings file, and they have one connection string. And they use that connection string for all of the database access they do across their entire application. Not really a good idea most of the time. Because if you look at most web applications, typically, you know, 90% of the app may just be retrievals. You're just getting data and presenting it. And then like 10%, 20% of the application does things like inserts and updates and deletes. Okay? And probably there's nowhere in the application where you're doing things like creating tables and dropping tables and stuff like that, yeah? So what I typically recommend to people is at the absolute minimum, right, your application should have two connection strings. One connection string that has only select permissions, and then one connection string that has insert, update, delete permissions, okay? So that way, in the 80% of your app where all you're doing is select queries, you use the query string that only has read permissions. And in those other places, you're using the connection string that has the insert, update, delete permissions. And nowhere is there any connection string that allows for DDL statements like drop tables and stuff like that. Now, can you go further than that? Absolutely, you can go way further than that. You can have 15 connection strings if you want, but you have to be careful with performance there because behind the scenes, .NET will use things like connection pooling to reuse connections, and that's based on the connection string. And so you're kind of defeating that pooling by using like tons of different connection strings, but at least have two. You could have stored procedures that have different permissions set for each one of those stored procedures, and that's fine. But again, at least two, okay? Because that gets you like 90% of where you need to be. And if you want to go more than that, well, that's fine. But at a very minimum, that's what I like to see, okay? Because that really goes against least privilege, right? Because I'll see applications where they've got 53 different queries. They're all just select queries, and they're all running with a connection string that has insert, update, delete permissions. All right, so that way you're like, yeah, there's no way injection can happen because I've done a really good job. It can't happen. But even if it does, the connection string that it's using doesn't have permissions to do anything except read. Nice. Okay, that's the way you want to be, right? Have those different layers of protection. Because yeah, you would never want to be one of those people that's like, can this ever happen? No, it can't happen. And then it happens. Oh, you just destroy all your credibility, right? All right, cool. Now, related to injection is a vulnerability that I'm seeing more and more often now, okay? And it's no surprise. When ASP.NET MVC first came out, everybody kind of knew it was going to happen. They said, developers are going to have this particular vulnerability in lots of places all over the, something called overposting. And this is one where you may be using something like web forms or what have you, and that's fine. But if eventually you start using ASP.NET MVC or Web API or ASP.NET Core, all of these different newer frameworks have a feature built into them called model binding. Now, model binding opens up the opportunity called overposting. And the best way to sort of explain what's happening here is to show an actual real live demo of this. And this is going to be the overposting demo project that's in your GitHub. So there's actually a Visual Studio project that has the code that I'm going to show you guys. So if at some point later you'd like to open up this project and sort of play around with it on your own, or extend it and modify it and do more stuff with it, then yeah, you're free to do that. It's up to you. Okay. So, and I'm going to show you what it's about here. With model binding, the idea is, and other frameworks have this sort of thing too. They just give it different names or something. But the idea is that the developers of the framework want to put something in place to help alleviate some of the tedious code that you have in your web applications. And one of the places where you've got some tedious code is dealing with the incoming data. So let's say we've got a form, and so the form allows you to edit an employee. So there's lots of fields, right? It's got, name and phone number and salary and all sorts of different fields. User fills out that form, they submit to the web server. Data comes into the web server. Now, typically what you want to do at that point is you want to take all this incoming data and push it into some sort of object, like the employee object. And once you've done that, then maybe you do some validation, check some other things, and then you're going to save that employee object to the database. Okay? Now, that process of taking all the incoming data and stuffing it into that object is code that I don't really want to have to write, because it probably looks something like, you create a new employee object, and then you say something like, employee last name equals request form last name, employee first name equals request form first name, employee salary equals request form salary, and just, I don't want to write that code. So in ASP.NET MVC, they introduced something called model binding. And the idea with model binding is that when a request comes into the application, the system can automatically populate that object for you based on what's coming in. So first of all, let's just take a look at our little application we've got here. So this is actually an ASP.NET Core app, but it works the same in MVC and Web API and everywhere else. We have well, first of all, before I actually show the form here, let me go back over here for a second. So here's our employee object, okay? So it's a C# class called employee, has ID, which is the primary key, first name, last name, phone number, and salary. So that's our business object, right? Our model. And so we have some database table somewhere that has columns for first name, last name, phone name, salary, phone number, and whatever, okay? Okay, so then what I end up doing is I create a little web application, and my web application has a form that you can use for editing an employee. So it looks like, this, okay? So there's first name, last name, and phone number. Now notice, I am not providing a text box here for you to be able to edit salary, because salary is something that you're not supposed to be able to edit using this web application, okay? That's a different web application or some other process or whatever. So when I create this form, these are the only things that you can edit. Okay, now, so the code for this. So here's my employee controller. So this is the thing that's going to be responsible for actions related to employees. Okay, so I have my edit method here. So what it does, it's going to receive some sort of ID, comes in as the URL or the query string or something, and it goes and retrieves an employee from the database. In this case, I just sort of create one, okay? ID, first name, last name, phone number, fine. I send this object, this employee object, to my view, and then my view creates some HTML. So here's my view, which is my form, where I have first name, last name, phone number, and the button, right? So no salary, no ID, okay? That's what I want. Now, when the user submits the form and it posts back to my server, that's this action down here. Now notice this action is receiving something of type employee. So the model binding system is going to kick in here, so that when this action gets executed, the model binding system is going to say, oh, you need an employee object here. Fine, I will go ahead and create an employee object for you, and then I will look at the data in the incoming request, and I will attempt to populate all the properties of this employee based on what's coming in the incoming request. So that way, when I get to this first line of code here that says save employee, I have a fully constructed employee from what's coming in, and now I can just go ahead and save this thing to the database. Now, when I go to save it to the database, if I'm using something like Entity Framework, which is Microsoft's sort of object relational mapper or whatever, I don't have to write the SQL. I can just tell EF, hey, save this employee for me. And then Entity Framework will generate the necessary SQL to go ahead and make that happen. and save it to my database, right? Super cool. If you go online and you look up like a tutorial for ASP.NET MVC or Core, this is probably going to be the first tutorial you do, which is how do I retrieve some data, send it to a form, and then get the form data back and save it to the database. It's great. And I don't have to write a whole lot of code, right? 2 lines of code or something. It's awesome. Okay, so if we want to see this thing happen, let me set a breakpoint right here on this return view, and let me run it again. And we'll try to edit our employee, and we'll supply some sort of value for the phone number, and we'll see what happens. So first of all, the model binding system is super, super convenient. I use it, you know, pretty much all the time in applications I've been building over the past couple of years. Love it, okay? But as we're gonna see here, it doesn't save you from having to understand how this thing works and how we can make sure and avoid getting ourselves in trouble. So here's my employee, and so let's change the phone number to 555-9999. We'll click the button to submit. So here we are back on the server, it's hit my breakpoint. So I hover over employee, and we look at the data that's in there, and I see that my employee object has Bill Gates, ID of 3, and the phone number is 555-9999. Beautiful. Now I can save this thing off to my database. Now, employee does have a salary property, because that's how I define the employee object. However, there is no salary in the request. Of course not, because there's no form field for that. So no salary came in, okay? So that's fine, no surprise. However, what would happen if I was to go over here to the browser, and let's go ahead and open up my developer tools. And what I'm going to do is I'm going to go to where my phone number field here is. I'm going to take my phone number field, and I'm going to go ahead and make I'm going to copy that element. We'll go up here, and I'm going to go ahead and paste that back in. So now I have a second phone number text box. But now I'm going to call this salary, and we'll change the name to salary. And we'll change the value to like 250,000. Okay. And now what I'm going to do is we'll go back up here, and so you can see I've actually got another text box here. And now I go ahead and do a submit. Arrives at my controller. I look at my employee, and now my employee has a salary value of 250,000. Because again, the model binding system doesn't care. The model binding system says, oh, you need an employee, so I'll go ahead and create one for you. And is there a salary in the incoming request? Yep, sure is. Then I'll go ahead and set it for you. Oh, thank you for that. And now if I use Entity Framework to go ahead and save this to my database, Entity Framework is going to basically look at what properties of the employee have been modified, of which salary is one, and then it'll generate the necessary update statement to change the salary in the database. You see why this is referred to as over posting, because what we've got is a post, right, a form submission to the server, and more data is being posted than what I'm expecting. Now, because I'm using the model binding system to do all the hard work for me, it's perfectly happy. It's like, yeah, whatever, sure, okay. Right? And so this is a very common vulnerability that we're seeing now in Microsoft based applications because of this system. Now, that doesn't mean it's a bad thing. Model binding is awesome, but you have to know that this sort of thing possibility exists and then make a decision about how to prevent it, okay? It's actually super easy to prevent. It's just, unfortunately, most of the tutorials and other things that you see kind of just ignore this because they're like, hey, we want to show you how to build an application with the least number of lines of code possible. Woo! And then people end up, you know, getting themselves into this trouble, okay? So, and again, this is something that's specifically an artifact of overposting, but I like this example and I like showing people this example, even if I have a room full of, you know, Java developers, because this is a good example of how a productivity feature, which, you know, the vendor puts into their product to help you, the developer, be able to, you know, be more productive, can open up a possibility for something that's not so good, right? And so that's why I tell people that when you're using these additional sort of helpers, you need to know how they work so you can make sure that you don't, you know, fall into this kind of trap. So in this specific example, how would I prevent a problem from happening? Well, first of all, back over on the slide, it says overposting, right? Blah, blah, blah. The model binding system will set every public property of an object if there is a matching request value, including properties that were not part of the form that were sent to the client. When a property is set by the model binding system that you do not intend to be set, this is referred to as overposting. Okay, so how can we fix it? Well, you got a few choices. In the slide, it says use a bind list on the action, use a bind list when calling up the model, use a view model object for binding that excludes properties that should not be set. So basically what it's saying here is in your action, there's a few different ways where we can specify, give the model binding system some help. In other words, we can tell the model binding system, hey, when this method executes, keep your hands off salary, ID, social security number, whatever, right? Or explicitly say, these are the things that are okay for you to set for me, right? Or on the object itself, so for example, on the employee object, you can put things like attributes here as well to help it tell the system which things are okay to be set automatically. Or a third approach, which is the one I typically prefer, which is to do this in sort of a more object-oriented way, right? To think in terms of being a good object-oriented developer. I have a situation here where, on one hand, you're editing an employee, but on the other hand, you're really not, okay? You're editing some information that belongs to an employee, but you don't have the ability to edit the entire employee. You're only editing sort of a subset of the employee, right? So instead of me fetching an employee object and giving it to the view, and then accepting an incoming employee object, instead, why don't I define a new object for this specific job? So I define a new class called, mini employee. Mini employee just has last name, first name, and salary. Or not salary, first name, last name, and phone number, no salary. I create one of those objects based on database data, send that to the view renders the form. Form gets submitted. What I receive here is a mini employee object that only has properties of first name, last name, and phone number. So those are the only things the model binding system can set because that's all that's there. Now, yes, I am going to have to turn that data into an employee object so I can give it the entity framework to save to my database. But in other words, I am defining an explicit object that contains just what I am expecting to receive. It does mean a little bit more work for me because I've got to take data from one thing and shove it into another thing and take data from here and shove it into there. But yeah, I don't have this opportunity for the model binding system to do more things than what I'm expecting, right? A lot of times in this scenario, we'll call that a view model object because it's a model that's being designed specifically for use by the view, which in this case is a form, right? You can call it a data transfer object if you want. We have different names for it depending, but yeah, so that's the approach I like in this case. And so again, it's about sort of the thought process, right? Which is, hey, I'm using some sort of mechanism here, which is saving me some time because it's populating this thing for me. But I'm asking those questions, those what if questions. What if too little comes in? What if too much comes in? What if what comes in contains a bunch of HTML or JavaScript? What if I'm asking all these what if questions. So in the case of what if too much comes in, then I might decide, okay, well, how do I prevent that? I could look for some sort of way to alter the behavior, or I just design the system slightly differently. So it's not accepting an employee anymore, right? So hopefully that kind of makes sense, right? So if at some point you end up being involved in an ASP.NET MVC app or a Web API app or a ASP.NET Core app, you should be able to say, sort of in a few words, what overposting is, and make sure that you don't have an opportunity for that anywhere in your application. Okay, it's a form of injection, especially when we have applications where, users cannot edit salary, but managers can edit salary. Depending on how you put the application together, there's a possibility for this sort of thing. Countermeasures for injection, okay? The primary defense against injection is through input validation, right? Identify the places in your application where you are working with incoming data, right? And then case by case at that point, right? But you should be able to identify each place in your app where you're working with something which is incoming, and then what do you end up doing with that incoming data, right? And then what the data is and what you end up doing with it is going to determine, what code you need to write there, okay? To check to see if it contains certain things or doesn't contain certain things, or if it's passed to a SQL statement, if it's parameterized, if it's, whatever it happens to be, okay? Request filtering should be used at the web server level to block improper requests as early as possible in the pipeline. I'm gonna go back to IIS for a second, because it's generally a good idea when we talk about something like blocking potentially bad incoming stuff, that we block that stuff as early in the pipeline as possible. Now, there's some things that are just very obviously bad, okay? Just because of the content that's being submitted, we know it's evil stuff. So we want to block that as early in the pipeline as we can. So that means either at the web server level, or if possible, at some sort of thing that even sits in front of our web server. So in the case of the Accelerate.com website, we actually use Cloudflare as our content delivery network provider. And so they have a web application firewall that sits out there before it ever gets to our server and blocks a lot of things that are just very obviously malicious. However, once it gets to the web server, there are some things that we can do to block incoming requests before they get to our code. So there is a module in IIS called the request filtering module. And the request filtering module has a bunch of options here for blocking incoming requests before they ever actually get to our application. Now, one of them is a file name blacklist. And so this list of things in here in request filtering says, if a request comes in for any that's requesting, has this file name in the request, just don't serve that, reject that. And we look at some of the things that are in here like .csproj, .config, .mdb, stuff like that. We also have something called hidden segments. So if a request comes into the web server and it contains within that URL web.config or bin or app data or app code, then reject that request. Sometimes I get ASP.NET developers and I tell them, hey, you know that nobody can request your web config file, right? If they type in, mysite.com/webconfig, the web server will not serve that. And they say, yeah, we know that. All right, good. Why? Right? Is it because it's called web config? Well, sort of, but it's not specifically because that's a special name. It's just because when you install ASP.NET here, it adds these request filtering rules. And so if it contains web.config, or also the file name extension config as well, then these get blocked early on in the pipeline, okay? So my file doesn't have to be called web.config, I would just have to update this rule, okay? And we have other things in here like restricting verbs, header values, query string values. If I go into edit feature settings, this is where I can set things like whether I want to allow unlisted verbs, or hey, these are our length restrictions. So a URL cannot be any longer than 4,000 characters, 4K, right? A query string can't be any bigger than 2K, and the maximum allowed size for the entire request cannot exceed 30 million bytes. Now, if we're not allowing big giant file uploads, then I can probably reduce that first number quite a bit, okay? This is also one of the things you can do to kind of reduce the opportunity for denial of service, because if we can just kick out requests that are over a certain size, it can help take the load off the server a little bit. Now, one quick thing I want to mention about this sort of stuff is if you start messing around with these maximum values, everybody needs to know this is happening, right? Because I've seen it where administrators will reduce these numbers to kind of lock things down a little bit, and then developers don't know they've done that, and then something doesn't work because their query string has gone over that value. So you just have to be a little careful. But the point I'm trying to make here is lots of options in the web server to do some of this request filtering and validation before it ever gets to any of our code. And so we do as much of that as we can, just to save ourselves. It's better for performance reasons and other things too, okay? Now, once we get past the web server's request filtering and we get to the point where the client data enters our application, we may want to do some additional validation, some additional filtering. That's just up to you to write code at that point, right? To decide, okay, what's appropriate here. You may use some regular expressions, you may do some other things just to check to make sure that what's coming in isn't something that you don't want to let in. The thing here says use whitelist-based validation whenever possible. That's true, but a lot of times that's just really inconvenient and difficult. Whitelisting basically says, you know, I'm going to explicitly list what is allowed, versus blacklisting, which basically says I'm going to allow everything as long as it's not one of these things. Okay. Whitelisting is more secure. Blacklisting tends to be easier to implement. So you have to choose there. Okay. But when you're writing your own validation code, you know, you try to do a good job, but you always improve it as time goes on, as best you can. The important point though is, as we already said, nothing coming from the client should be trusted. So that includes things like hidden form fields, select controls, cookie values, all that good stuff, right? Okay. Also with SQL injection, we already mentioned making sure that our connection string is, you know, least privilege. But also you can be a little creative too, right? Think about the SQL that you send to your database. If you've got a SQL statement that's only you're only expecting to get one row back, then you can put a top one in there. So then if somehow, some way, somebody is able to monkey with the where clause, you're still only ever going to get one row, right? Because that part's not dynamic. So that's, you know, static in there. So, I don't know. I've never actually done that, but just trying to show you an example of like thinking about ways to kind of be creative to, you know, mitigate the damage. So even if something bad were to happen, it's not really that bad. Client-side validation. So we've got a web application, and should we do some data validation on the client in JavaScript? Sure, absolutely, definitely. Why? Well, it's a great user experience. If I've got a user that has to fill out some big long form, I want to be doing data validation in JavaScript in the browser on the client. So if they type something in, it's not in the right format, I can tell them instantly, right? Oh, you need to have dashes in here or parentheses or whatever. Or if there's some required fields, they click the button, I tell them immediately, these 3 fields are required, please supply something for these 3 fields. It's great. However, can't depend on that, right? Client-side validation does absolutely nothing when it comes to from a security point of view, because code on the client is easy to get around. I can just delete the JavaScript. I can just send the HTTP request directly, lots of options. So client-side validation is really nice to have, but it's just because we're trying to give our users a good experience. Security-wise, useless. So I can do all my validation on the server, or I can do the same validation on the client and on the server, okay? But I can't do it, I can't depend on anything that's on the client. I saw an example a while back where it was a e-commerce type situation. There was like a checkout page, and on the checkout form, there was a form field where you could put in like a coupon code, right? Sometimes I'm gonna get confused with what I already talked about, what I talked about this morning, but I didn't do this yet, right? Did I? No? Okay. So the place where you can type in a coupon code. So the way they implemented this was, you add a bunch of stuff to your cart, then you go to that little thing on the page, type in your coupon code, you click a button. When you click the button, it makes an AJAX request back to the server and submits the coupon code. The server validates the coupon code, makes sure it's valid, figures out what that coupon code is worth, so like 10% off. Server sends back a response, says that coupon code is good and it's worth 10% off. So the JavaScript gets that response, displays a little green check mark, says, yay, yes, you get 10% off, woo! Calculates what 10% is off of the total, stores that away in a hidden form field somewhere, or the value of the coupon code, computes the total, everything else, everything's good. Then the user clicks the button to charge their card, submits the form to the server, and then the server takes the stuff that's in the hidden form fields and uses that to then decide how much to charge their card and charges their card. See the problem, right? So I was like, well, how about we do this? And so I brought up the form, I typed in a coupon code, the coupon code gave me 10% off, it stored that information in the hidden form field, I opened up the developer tools, went to the hidden form field, changed it from 10% to 30% or 80%, submitted the form, and then got a lot more money off. So that's just what happened, is they just kind of lost track of what was happening on the server versus what was happening on the client. In that they were doing it correctly, in which they were, sending the request back to the server. The server was validating the coupon code, figuring out how much it was worth. That's all proper, but then they didn't take it the rest of the way. Yes, you need to send the response back, give the user some feedback, show them the total, everything else. But then when the submission happens, you've got to sort of redo some of that coupon code validation, other things, right? And recompute the total, not just trust what's coming in from the client. Okay.